Alright, so molecular compounds, those that have covalent bonds, have both a molecular formula that tells you which atoms, which elements, in which ratios, right? This is 1 carbon to 4 hydrogens. That's the molecular formula. But it also has a structural formula, because it's possible that one molecular formula actually has more than one structure, which means more than one actual compound. Kind of confusing. So let's write a structural formula for carbon tetrahydride. So I'm going to put the carbon in the center. I'm going to surround it by the 4 hydrogens. Carbon will always go in the center, and we want to make things symmetrical around it. And here these lines represent the bond, the shared electrons between the hydrogen. Okay, so this is a structural formula for carbon tetrahydride, pretty straightforward. But there are some formulas where it's not quite so straightforward, because what you have, if I could advance, is here we have a molecular formula. We've got 4 carbons, 8 hydrogens, 2 oxygens, the molecular formula. But it turns out there are 2 different compounds that share this molecular formula. And if we look at the 2 structures, the structural formulas, in each case we have 4 carbons. In this one we've got a double bonded oxygen in an O with an H at the end of the molecule on the last carbon. And here we have this double bonded oxygen and another oxygen sandwiched between 2 carbons. Okay, well this causes the actual properties to be different. This is butyric acid, and if you had a sample of it in a test tube, it would smell putrid. And here we have ethyl acetate. You smell that? That's going to smell sweet. So it's not just the smells that are different, but all their chemical properties or physical properties would be different. Okay, so we need to know how to write not just the molecular formula, but we're going to learn in the next podcast how to write structural formulas for compounds. Okay, so that was a